Now we will discuss when rays are trying to enter from denser medium to rarer medium. Suppose it is glass, it is air. Rays are trying to enter from denser medium to rarer medium. It is the original path. Since they are moving from denser to rarer, they will move away from normal. Means you can observe that angle of refraction is greater than angle of incidence. If you will increase the value of I, value of R will also increase. And it is boundary of separation. Since refracted ray is near the boundary of separation, so what will happen? The incident ray will reach boundary before that. Before that, that refracted ray will reach the boundary. It means when you are increasing I, R is also increasing. So you will get one angle for which the refracted ray will reach the boundary. Means R will become 90 degree. What will happen after that? After that, no refraction. Now rays will bounce back to original medium. After that, rays will start coming to original medium. Means refraction end and reflection start. This type of reflection without mirror is known as total internal reflection. In optical fibers, we are using this concept, total internal reflection, and value of angle of incidence at this point. When R is equals to 90 degree, it is known as critical angle. So according to the Snell's law, rays were traveling from G to A. Mu means sin I upon sin R. Sin R was sin 90 and sin 90 is 1. So you can write sin C is equals to G mu A or 1 upon A mu G. On this concept, they are framing so many problems in competitive exam. One is this: suppose a fish is in water. A fish is in water. And it is looking outside. Suppose you want to see outer world from this point. It is I, it is R. It is okay. She can see the objects which are outside the water. But if she try to see outside from this point, what will happen? At this point, angle of incidence will change. You can observe that for this point, angle of incidence is increasing. It was less, now it is more. So if she starts to see outer world from this point, again it is on increasing order. At some point, it will become C. After that point, rays will not go outside and she is unable to see the outer world now. It means on both sides at same distance it will happen. It means to outer world she can see only from a circle. After that circle, rays will totally internally reflected. Means they will come back inside the water and she will see the objects which is inside the water. So she can see outer world from which circle. Its radius depends upon its position. If she go down, in this way she can reduce the angle of incidence. Now she is able to see the outer world. Angle of incidence is reduced. So you can calculate the radius of that circle from which she can see the outer world by the formula h upon under root mu square minus 1, where h is the depth of fish and mu is the refractive index of water. It is a very important relation for competitive purpose. Second thing about, we are discussing about refraction through plane surface. Now in plane surface, one important surface is prism. Prism, what is prism? Prism is a transparent medium bounded by 3 rectangular and 2 triangular faces. It is the cross section of prism. This angle is known as prism angle. When rays are entering in the prism, first refraction rarer to denser. It was the original path, but due to change in medium, rays will travel in this path. Again, now from denser to rarer, away from normal. First towards the normal, then away from normal. So finally, rays are on this way. It is known as angle of deviation. It was angle of incidence. It was angle of refraction for first surface. It is angle of incidence for second surface. It is angle of incidence for first surface. It is for second surface angle of incidence. It is angle of emergence. If you change the value of I, the delta will change. If you go to plot the graph between I and delta, it is delta, angle of deviation, and it is angle of incidence. You find this type of graph. Means if you increase the value of I, first delta will decrease. After a particular value, it will start increasing. This angle is known as angle of minimum deviation. When prism is in the position of angle of minimum deviation, at that time I is equals to E. At that time R1 is equals to R2. And you can calculate mu of material of prism by the formula sin A plus delta m by 2 by sin A by 2. At the time of minimum deviation, you can calculate prism angle A by R by 2. R1 and R2 are equal, and we know the relation of R1 and R2 with A. You have derivation in your 12th class. At the time of minimum deviation, R1 and R2 are equal. We are taking them R. So you will get R is equals to A by 2. And relation between I, E and A and delta is I plus E is equals to A plus delta. At the time of minimum deviation, I and E are equal. So we are getting I is equals to A plus delta M by 2. Since sin I by sin R is equals to mu, so we are getting this result. So it is an important result for prism. But prism is not only deviating the ray from its path, it is doing one more work there. It is breaking the light into its components. It is resolving the light into its components. You know that white light is not a single ray. It is the combination of 7 colors. And that 7 colors are this is the 7 colors: violet, indigo, blue, green, yellow, orange and red. Wavelength wise, they are on increasing order. And we know that refractive index depends upon wavelength. This relation is known as Cauchy's relation. It means high wavelength means low refractive index. So mu wise, they are on decreasing order. And just we saw that what was mu? Mu was sin A plus delta M by 2 by sin A by 2. For a thin prism, means if prism angle is less than 10-12 degree, no need to write sin. For small angle, sin theta is equals to theta only. So you can write this like this. Cancel 2 with 2. What you will get? Delta M is equals to A into mu minus 1. It means high value of mu, high value of angle of deviation. When 7 colors travels together towards the prism, what prism will do? Since for all colors value of mu is different, so all deviate with different angle. Angle of deviation is more for violet, less for red color. So what will happen? You will get red color nearer to incident ray, original path, and violet color away from this original path. If you take back to these colors, angle between these corner colors is known as angle of dispersion. And this phenomena, when light is divided into its component colors, is known as dispersion. And this angle of dispersion you can calculate by the formula A into mu v minus mu r. For deviation, we have this formula. If you take mean of the refractive index of violet and red color, you will get refractive index of yellow color. That's why we are saying yellow color is a mean ray. For mean ray, angle of deviation is A into mu y minus 1. And ratio of angle of dispersion and deviation for mean ray is known as dispersive power. So you can see that if you take ratio, A will be cancelled out. It means dispersive power only depends upon the material of prism, not on the construction of prism, because prism angle is cancelled. So it is dispersive power. So for single prism, two events are happening there. Number one, when light is going through a single prism, it is deviating from its original path. Number two, it is divided into its component colors, 7 colors. Dispersion and deviation, both are present there. But if you want to finish one of them, you have to use more than one prism. See, if I am using two prisms, now I can cancel either dispersion or deviation. How I can cancel them? Suppose I want to cancel deviation. It is first prism, it is second prism. For first prism, what is deviation? Suppose delta y. What is deviation for second prism? Suppose delta dash y. I want to make total deviation 0. What was the formula? A into mu y minus 1. For this second prism, I am taking A dash mu dash this. So what I am getting? A upon A dash is equals to minus. Take this on that side and this ratio there. Mu dash y minus 1 upon mu y minus 1. It means if you have two prisms of different materials whose angle of prism are in this ratio, and minus means you put prism like this, prism angle should be in opposite direction. You will not get deviation. Deviation is finished. No deviation. Similarly, you can get a light without dispersion. If you make theta plus theta dash 0, you will get no dispersion. The combination of prism for which total dispersion is 0 is known as achromatic combination. So in this way, we can finish deviation, we can finish dispersion. We need two prisms of different materials whose prism angle should be in a particular ratio and should be in opposite direction. So it was all about prism. After prism, we are moving towards refraction through curved surface. Again, like mirror, curved surface are of two types. It is convex or concave. It is concave. It is your object. You know the derivation? Ki if you are observing the refraction through curved surface, what you will get? Mu upon V minus 1 upon U is equals to mu minus 1 upon R. What is mu? Mu is the refractive index of this medium with respect to this medium, means rarer medium. What is V? V, where you will get image of the object. What is U? Object distance from the surface, this point, it is U. Where you are getting image, that distance from this point is known as V. So according to this formula, you can get the position of image. But what is happening in lens? In lens, you are using two curved surfaces. So lens is either of this type or this type, or you can make this type. So many type of lenses you can form. In this type, both surfaces are concave. So it is known as biconcave lens. Both surfaces are convex. So it is biconvex lens. It is one surface plane, one convex. Plano-convex. So in this type of figure, a refraction will take place twice. Once rays when enter from rarer to denser, then they will enter from denser to rarer. It means if I put the object here, first surface will make one image. Then second surface will make final image. You know the derivation. We get where we will get the final image. You can calculate by the formula 1 upon f is equals to 1 upon v minus 1 upon u. One more formula was there, 1 upon f is equals to mu minus 1 into 1 upon r1 minus 1 upon r2. What are r1 and r2? R1 and R2 are the radius of curvature of these two surfaces. To which surface light strikes first, its radius of curvature is known as R1. And after that light strike to second surface, its radius of curvature is R2. We know that focal length of convex lens is positive. Focal length means parallel rays after refraction from lens will collect at which point? Distance of middle point of lens. From that point is known as focal length. What is this middle point? This is known as optical center. Any ray which will pass through this optical center will pass undeviated. It is optical center. And by this result formula, you can make a lens of desired focal length. So it is known as lens maker's formula. And it is lens formula, just like mirror formula. And the ratio of image size and object size is again magnifying power or magnification. In lens, it is given by plus V upon U. In mirror, it was minus V upon U. In lens, it is plus V upon U. Now, which type of problem only based on designing of lens they can ask from you? See, if I am asking you कि I have this convex lens, I cut this convex lens in two equal parts. If initially focal length was f, it is a equiconvex lens. What do you mean by equi? Equi means both radius of curvature are same. What is the focal length of one part? Is it same or it half or double? They can frame 3-4 options. See, it was equiconvex lens. According to lens maker's formula, if radius of curvature of both surfaces, I am taking r, focal length of lens was r. So 1 upon f was mu minus 1 into 1 upon r1. R1 is positive because you can see it is convex lens. If I complete sphere for this, its center of curvature is on right hand side. I told you in mirror we are using coordinate system. Distances on this sides are positive. So R1 is positive and R2 is negative. So minus minus, it will become plus. So what we are getting? 1 upon f is equals to mu minus 1 by into 2 by r. Now for this lens, what should be f? Material is same, mu minus 1. 1 upon r1, again same. 1 upon r2, second surface is plane and radius of curvature of plane surface is infinite. So what I am getting? I am getting mu minus 1 by r. Multiplying, dividing by 2, I am getting this. And it is 1 upon f. So what I am getting? 1 upon f dash is equals to 1 upon f into 2, 1 upon 2f. So what we are observing? That focal length will become double. So focal length is double. So getting my point? So they can ask this type of problem in convex lens and concave lens. Second type you are doing from 10th class. They will give u and v, they can ask f, they can give f and u, they can ask v, they can give you f and v, they can ask u. Now, after lens and where you put object, where you will get image is same. What we did in mirrors, what you get for convex mirror, you will get for concave lens. And same table which we make for concave mirror, same will be work for convex lens. So no need to learn differently. Next, now power of lens, or if you are using more than one lens combined. So for how to calculate the focal length of combined lens? For combined lens, 1 upon f is equals to 1 upon f1 plus 1 upon f2 dot dot dot. And remember that reciprocal of focal length is power of lens. If focal length is in meter, formula is P is equals to 1 upon f and unit of power is diopter. But if focal length is in centimeter, power will be 100 upon f. Formula is again unit is same, diopter. So if you are combining more than one lens, for combined system, you have to apply this formula 1 upon f is equals to 1 upon f1 plus 1 upon f2 plus 1 upon f3 like this. So now we will discuss little bit about optical instrument. First of all, there is simple microscope. A single convex lens is used as simple microscope. We have derivation in 12th class and we also completed in our theory part. So you know that the magnifying power of simple microscope is 1 plus d upon f. F is the focal length of lens. 1 plus d upon f. If final image is formed at d distance means least distance of distinct vision if final image is infinity at infinity, then magnifying power is simply d upon f. In this we are using the concept, we are putting the object between the optical center and focal point. You will get one enlarged image which is erect and virtual. So in this way we are using a convex lens as a simple microscope. But when you are using two lenses, it is known as compound microscope. Two lenses, the lens which is on object side is known as objective, which is on image side is known as, or your eye side it is known as eye lens. So that time we are saying it is compound microscope. To differentiate two lenses, for one I will write O, for one I will write E. Objective lens and second is eye lens. So what is the formula for compound microscope? For compound microscope, for one lens we are using a simple magnification formula V by U. It is objective lens. For second, we are using, second lens is behaving like simple microscope, means 1 plus D upon F. So it is the magnifying power of compound microscope. Means double magnification is there. Objective lens, simple magnification V by U. For eye lens, it is behaving like simple microscope. So you are getting this formula. And tube length of microscope, it means distance of object from objective VO plus UE. It is known as tube length. Second instrument is telescope. What is difference between compound microscope and telescope? Microscope is increasing the size of image, and telescope is taking object nearer to your eyes so that it can make a big angle at your eye and you can see clearly. Means if I am saying magnifying power of microscope is 15, it means it is increasing the size of object 15 times. But if I am saying magnifying power of telescope is 15, it means it is taking object 15 times nearer to you. Two types of telescope basically are there. One is to see the object on earth. They are known as terrestrial telescope. And one for stars, planets is known as astronomical telescope. So for first I am discussing about astronomical telescope. Astronomical telescope. What is the magnifying power? It is FO upon FV into 1 plus FE upon D. FO means focal length of objective lens. FE means focal length of eye lens. But a final image, in this final image is at D distance. But a final image is at infinity. M is equals to FO by FE. What is the difference between astronomical telescope and terrestrial? In astronomical telescope, final image is inverted. Since planets, stars, they are of round shape. So if image is inverted, no problem for you. But for terrestrial objects, we need erect image. So we are using a third lens whose magnifying power is 1. Means not changing the magnifying power of your operator. Your instrument, it will remain same. Only it will invert the final image, which was inverted. Again, if it is inverted, it means final image should be erect. It will be erect. So only we are using 3 lens, means it is objective lens, it is making one image, it is eye lens, it is making second image. Since final image is inverted, we are using one third lens, which will only erect your final image. So it is known as erecting lens, and we are using the property if one object is at a distance 2f from a convex lens, where f is its focal length, it will make same size image on opposite side at 2f distance, which will be erect. Means with respect to this image, it will be inverted, but with respect to your object, it will be erect. So it was all about telescope and microscope. After that, some small thing, only eye defects are there. What are eye defects? There are 3 types of eye defects are in our physics syllabus. One is myopia, if you are unable to see distant objects. Second one is hypermetropia, if you are feeling trouble to see nearer objects. Third is due to age difference, old age. When your ciliary muscles are weak, your power of accommodation will decrease. Means ciliary muscles cannot put proper pressure on your eye lens. Then you will get both type of defects, myopia and hypermetropia. To correct myopia, you need a concave lens of proper focal length. To correct hypermetropia, you need a proper focal length convex lens. To correct presbyopia, you need a bifocal lens. Initially, there was one fourth defect was in syllabus, astigmatism. In one direction, you can focus the rays your sight, but in perpendicular direction, it is tough to see. Clarity is not clear, so that was known as astigmatism. But now we have only 2 defects, mainly myopia and hypermetropia. To solve a numerical related to myopia and hypermetropia, we have to use only lens formula. 1 upon f is equals to 1 upon v minus 1 upon u. Where is your object? Where you want image? Both will be given, and you can calculate easily focal length. Remaining eye is also in syllabus in your bio syllabus. So you are aware of all things. What is aqueous humor? What is vitreous humor? What is the refractive index of eye lens? Refractive index of eye lens is 1.437, and refractive index of aqueous humor and vitreous humor is 1.34, and the for lens you have, it is in nature crystalline lens, but your eye lens in nature it is convex lens. Screen is your retina. Pupil is allowing only that light which is sufficient to make a proper image. Extra light is absorbed by that black color pigment which is inside the eye in interior chamber. So we need only this lens formula to correct the defects of eyes. You will get where is your object. Suppose you want to see stars, but you cannot see object more than 4 meter. If it means you want image of star at 4 meter. So which type of lens you need now? Since in this type of problem, image is on that side on which side object is there. So we have to take V and U both negative. So V is 4 meter, means 400 centimeter. U is, object is at infinity. So you need a lens of focal length minus 400 centimeter. Means its power should be 100 upon f. Means minus 0.25 diopter. So now we will try to solve our 45 problem assignment on ray optics.